So in the today's session, we are going to discuss about the introductory information about the artificial intelligence, then machine learning and its security aspects. So the schedule, I think you people know, right? The topics that we have to discuss in this session. So we'll primarily discuss about the theoretical foundation about the AI and machine learning. Then we'll go to the little advanced topics, the current state of art, and then following sessions will carry on from that, right? So the first session will try to little motivate all of you, so that your interest becomes more towards the CPS and security aspect. So before going to further, so we can say here, so AI in cyber security. So cyber security in cyber physical systems. So I think in the inaugural session you might have got the information of the cyber. So we are securing the CPS, or you can say physical systems, mostly the devices, IoT devices, or the devices which are connected through internet, IoTs you can say. So we try to see that how can we secure them against several attacks, right? You can say those attacks might be software driven, that might be hardware driven. So we'll discuss both the things, and a few type of attacks we try to do as hands-on, and we try to develop some models which can defend, provide defense against those attacks in this 5-day basically sessions, 4-day session that we'll going to conduct. These are the application areas you can see here. So you can say usage of AI in cyber security, you can say starting from the malware detection and prevention. So many of you might have done the assignments, or you can say you might have done project to basically detect between the genuine, or you can say having and spam data, right? So one of the popular example is basically spam email and ham email classification. So whether the email is generated, or you can say written by some legitimate or legal user, legal person, or it is just some spam or with malware intention the mail is given to you or sent to you. Then phishing and email scam detection, vulnerability management and patch prioritization. So this one is very important. So you know the device drivers. So whenever we write a program for device drivers, so during that time you can put some malicious code inside that device driver program. So mostly you know that device drivers program are basically installed on firmware or some sort of some layer of the operating system, right? So they can, so what is the harm? So they can put the malicious code, so they might not harm your system. They can act like a Trojan. They can just basically take your information, and whenever they are connected to the internet or networks, so they can transmit your information on different clouds nowadays. And it is not new. So these type of attacks are from many decades, right? So earlier days when the Xerox machine was there, right? So Xerox, so it was developed in USA. So you might have heard one case against Xerox, I think 15 or 20 years back. So what they were doing, so most of the defense units in across the different countries, right? So people are purchasing those Xerox machines for just copying the data. And that's the reason most of the US has lot of information from all the countries, defense countries. So whatever data they were basically scanning through that Xerox machine, so that was sent to the USA defense unit. So that's the reason they were controlling, because they have your data, they know your missions, they know that what you are going to perform in few decades, right? What type of innovation, what type of program, defense program you are running. So that's the reason, and then it was challenged in the code, and then lot of chaos happened, and that attack was due to the vulnerability management and patch prioritization. So they put the Trojan in their hardware, so no one is aware of that. So even nowadays you can find lot of Trojan maybe on different type of mobile devices that we are using right now. One of the another case, if you remember, right, on the attack was Alexa, right? So Alexa type system, I think many of you might be knowing. It is not costly, you can purchase, right? So Alexa, so people uses it in home for just you just put some commands, so it can basically switch on your light, switch on your AC. Your Alexa can listen you, can provide video. They can take your video. Nowadays people use for telephonic conversation, right? So if you have Alexa in your basically hometown, many Alexa, so you can communicate with each other, right? So like a telephone, video telephone you can just do. So these devices somehow the study, most of the countries, even our country, pumping money to study the vulnerability or the threat attacks, basically threats towards these devices that are IoT devices. And not only our country, so many countries are basically working in that. So they are calling cyber physical system test bed. So idea is you just have a mobile phone, you just clone all the software that you have in the mobile phone on that system, that test bed, and the task of that test bed is to identify whether your device is vulnerable towards certain threat or not. So whether it is taking your information and sending to some cloud or not without your permission, or what type of information that particular device is basically capturing from you and sending. Because many times what we are saying that our mobile is basically in silent mode, or audio is off, or video is off, but actually these devices many times they are awake. And you can sense many times if you are discussing something in your home, in your office, right? So maybe later on you can say that recommendation system, if you search, crawl on Google or some place, you will see a lot of things they are giving you, pushing you like as a recommendation products. You will see that why they are sending this to me. I was discussing in my home, right? So I just discussed this thing with my friend only, but we are getting recommendation, right? So suppose you are talking about the good shoes in your home, your mobile is silent, right? You are not doing anything, but later on you will see that you are getting recommendation for different type of shoes and other things. So that's a challenge. Without your permission, without your awareness, these devices are basically taking your data and they are syncing on their cloud. And many things we are installing, by the way, so many apps we are installing just for our ease, and most of the apps are basically free in nature, but you have to sign certain agreement. If you are installing any app, they say that okay, we need your camera access, we need your audio access, right, microphone access, they need your gallery access or folder access, and if you don't allow, so those apps will not be installed, right? And this is a challenge. And then they say that like Google and other apps, basically I'm not saying that the apps that are on Google Play, all the apps that are on Google Play, so that are not owned by Google. So that is a platform, so Google provides where anyone can put basically their app and user can install it. So they have certain parameters to check the security, but not exhaustive. So that's a challenge. So but Google, whenever you sign any Google products, right, so they give you the agreement and they say that okay, we'll need your data for just research and development purpose, so we're not going to share it to other. So you might remember the case, Facebook was basically selling the data, Indian basically community data to Cambridge Analytica. You might have heard during the Gujarat election. Do you remember? Right. So that was a huge basically chaos at that time, right, in political system, that people are these social media sites are selling the data to some software companies who basically analyze and they will basically prioritize, or you can say somehow mobilize the political situation in the country. And this is the basically true story even nowadays. So this perception building on social media platform, you can say that if you flood many bots, right, who just write information against someone, right. Right now we have a lot of AI tools which can generate fake information, right. They can do it very nicely, like audio cloning, voice cloning. You can do video cloning, and you can harm, right, to any personality, any person, and people can change the perception. So even in these attacks, so whenever we say that attacks, so if you harm around, suppose you have made certain attack model and it is capable of attacking system about 10% or 20%, then you are successful, right? So that's the story behind the attack, that the motivation behind the attack. So if your attack is 10% successful, then it's very good, right? So for example, in the country you have in India we have 1 crore, right? So 140 crore, 40 plus. So I think currently we have 145 plus, right? Crores of people. And if you see the electronic devices, IoT devices that we have, so many million devices we have in India. So that's why people look India as a global market nowadays. So we have millions of devices, and suppose someone has put certain malware on your maybe at hardware level or at software level. So they are basically stealing our data without our knowledge, right? Without our basically authentication. Then that is a challenge. Like the pager attack, you might remember, right? Israel and Hamas fight. If you see that if you say that every IoT device that is basically developed at certain foundry or at certain design industry, so they put certain Trojan like that, so they can harm a lot to the society, right? So that's a challenge. So given a device, given a handheld device or IoT device, can we identify whether this device is threatful or not, right? That can be a threat for us or not. So that's a challenge. So in this discussion, in this FTP, I think from start to end, so we will see different aspect of these threats and vulnerabilities. We want to basically, our aim is to basically tell you about the threats, how the threats are basically attacks are designed. Because if you don't know how attacks are designed, you can't get the solution. You can't defend it, right? For example, if you have antivirus, so how will you develop antivirus? Because most of the vulnerabilities you don't know a priori. If you know a priori, you can put the patches, you can develop the patches, defender patches in the OS itself. But even after designing those known vulnerabilities, we design the patch in operating systems. So that's the reason we have different security patches even in our Android OS, right? iOS and maybe other form of the OS that we have in IoT devices. In our system we have operating system, we have different versions. So every version has certain security patch. So what they do, so they try to basically build the model which basically defend against the known vulnerabilities. And every day you know that lot of attacks are happening and lot of basically defense model are developed. So they try to patch the current state of art defenders, right? So Windows Defender you might be knowing, right? So people say that if you have installed your basically OS comes with Defender module, so it is not vulnerable. So please say that your OS is secure, but it is not true. Even you have a Windows Defender, but your system is vulnerable towards certain type of viruses, right? Threats. If you install some executable or some patches, so those comes as a gift for you, right? So viruses comes as a gift to you, right? So that gift basically harms you in some sense. So you have to develop new algorithm, new approaches to defend those attacks. So that's the market of antivirus. So many times people say that there is a myth that people say that the company who send the threat are basically who basically design virus, so they also design antivirus. At one point of time it might not be true, because without knowing virus and its basically action or the things that your virus is basically the actions that is performed in your system. So if you don't know that what is the type of virus, what is it doing, you cannot develop a system which can defend against that, right? So that's why it has two basically sides of the coin. So if you don't know attack, you can't defend, right? If you don't know that how the basically thief enter your room or enter your home, and some costly things have been stolen. If you don't know that how was it happened, you cannot make secure your system, your home, right, against those type of you can say intruding, right? So that's a challenge. So if you want to study the defense model, so defense we say that it is in good basically humor. But when we say attack, so attack comes with some negative mindset. But if you are having positive mindset, your aim is to basically develop a robust system which is basically defends you against certain type of attacks or different type of attacks, then that is basically innovation. That is basically good for the society you are developing. But if you are designing only attack so that none of the system can detect those attacks, then that might be another story of the coin, you can say, another side of the coin. So that is basically your aim is to harm the society, harm the system. And this perspective basically changes. If you are in defense, your task is to basically protect your country, protect your system. If you are in civil society, your task is different. So if you are in civil society, if you are a civilian, so your task is to basically shape the society, right? To do the things, to develop the things which is beneficial for the society. But at the same time, if you are in defense, your aim is to basically protect your borders. So you have to protect your border from different type of attacks, right? Maybe one is the intruding attack, so no one can enter your border. So the thing that we are developing for those are whatever we are doing for other countries. Suppose our country, many countries are basically sending some threat to us, they are harming us. So there are two things: either you accept them, just be quiet, whatever they are doing, let them do. If you want to respond, then you have to also send the threat. You have to also give some penalty, right? Some losses, some harm to those countries, right, who are basically harming you. Then the perception changes. So that good thing, that was bad thing in the society, it is good for the country when it comes to the security aspect, defense aspect. So that's why we, in this due course of time, we'll show you the capability of AI models nowadays. So lot of work can be decided using AI tools nowadays. You have not to physically send any person to attack. You can send devices for attack, right? Like drone attack you might have heard. So you can say these wars like Russia, Ukraine, Israel, Hamas, and maybe with other countries, you can see that a lot of AI technology is used nowadays. So if we say that, okay, we are very liberal, we are very positive mindset people in the country, we will not do any harm to others, that's good thing, we should not. But at the time, what will happen, you will be very back, or you can say very behind from the current state of art, current state of technology that people are doing. So if you don't do, other will do, right? It is not true like you say that, okay, we will not develop missile program, we will not develop nuclear program. It is good, right? You should not, you don't do. But at the same time, if someone threatens you, they say that, okay, I'll attack you with nuclear products, or you can say nuclear bombs, or some other nuclear programs. So what will you do then? You have to also develop your technology for that, right? So attack and defense comes together, right? We have to build the model, we have to build the powerful model so that we can protect ourselves at least, right? So that's another story, that is the midway story, you can say, that between attack and defenses. We say that we are going to develop, we are going to innovate to protect ourselves, right, to protect our model. So the recent story about the lot of market breakdown, just the introduction of DeepSeek model, AI model. So what is the reason? The reason is that ChatGPT was a commercial model. They invested a lot of money to develop it. Now they are basically charging it from the client, from the industries who are basically going to use their conversational AI model. But if someone comes and says that, okay, we are giving you the similar facility or more than a stronger facility in free, as an open source, you can customize it according to your need. You can put your own security patches. So why do we go for paid version or commercial model like ChatGPT and others? So that made huge, loss to these companies. So a lot of share basically went down for OpenAI and Microsoft, right? And you know that story. And this is just I think few days back, right? So this is true here. So what happened? Sorry. Right. So that's attack, you can call it attack. We call it cloning attack in some sense. So one model is available on cloud. So all these models are on cloud, right? So GPT or Google Gemini, right? This DeepSeek is also available on cloud. So if you say that any model is available on cloud and you can clone that model. Clone means you can develop a model which is capable of doing similar thing, and you just put it as open source. One model is commercial, which is basically charging money. Another model is available as open source. So people go for open source. Because you have flexibility in open source, you can put your own patches. You can customize it according to your own needs. For example, the same is true for Linux operating system. So I think many of you knowing that Linux operating system, you can change the kernel, right? At any point of time, you just write your own program, and you can put in these flavors, Linux flavors, and you can customize OS very well. But if at the same time, if you go to the Red Hat, it is a commercial version. You don't have anything to do there. If you go to the Windows OS, so these are commercial in nature, so they will say that, okay, you are violating the copyright. You can't do anything. Another one is Mac OS. So that is very older, the first OS, right, Mac OS, then I can say Linux was developed as open source. So the same story is true here for AI models nowadays. People come with different commercial versions, then within few months, within few days, another people comes with free version. So that's the rapid growing, you can say rapid transformation in this AI technology nowadays. So you have to meet the pace. So if you want to meet the pace, you have to be basically alert. You should have a compute power. So if you have compute power, because you cannot develop ChatGPT like system or DeepSeek based system with low resources. If you don't have thousands of GPUs, even you cannot think of just doing one epoch or training one epoch, right? So that's the challenge, and many countries facing this one. So only the countries which has this power, compute power nowadays, so they are winning the game. So they are in the pace right now. We are also racing behind those things, and of course in few years, coming years, because government is pumping a lot of money to do research in AI in different aspects of the country. For example, healthcare, for example, in defense technologies, in academia, right? In transportations, in tourism, in content design, right? So we are doing it. So that's why at the same time we need the security. We have to provide the security. Otherwise, people do a lot of harm to us. Lot of loss we have to bear. Because if we have a dream of a smart city, right? So a smart city you cannot dream without AI. It's everything we need autonomous. So if you want everything autonomous, so manufacturing should be done, should be controlled in your hand. Right. So any development process, if you involve third party, you cannot you can say that what might happen to your basically AI model or technology. So that's why we have to basically change this ideology that we are just buyer of the technology. How we have to be the producer of technology. Then you can think of all these security aspect. Otherwise, people say that security is a myth. If we are borrowing, we are basically purchasing the chip from foundry, which is basically established in USA, established in China, established in Taiwan. So largest semiconductor manufacturing in the foundry is in Taiwan, right? TSMC. आप लोगों ने कभी नाम सुना होगा जो हार्डवेयर सिक्योरिटी में काम करते हैं. So you have to design a chip, right? So if you have design diagram and you want to get it produced, you have to send your design to these foundries, TSMC in Taiwan, maybe few in Germany, USA foundries, China foundries. So production is in different hand, right? They can put some malicious thing in your design that you might not exhaustively find that what happened to our chip, right? In India we have SCL, right, Semiconductor Limited, but nowadays you can say we have National Semiconductor Mission, so NSM. So through NSM we are moving in that direction. We are basically trying to develop manufacturing industry here, so that whatever design you have, security design, or you have developed certain AI chip, you can AI design, so you can produce it in India only, right? So you can have control on those. So you can do lot of things in defense technologies. So we can develop our own. So right now we are relying on these global foundries. Right? That's a challenge. Okay, so then you can say enhanced threat detection and analysis. So one of the thing you might have heard, zero-day attack. So we are planning to basically defense against zero-day attack. So zero-day attack is once attack comes to you. So if you have a defender module, so many of the attacks, if your defender module knows a priori, and it knows that it has defense mechanism, so it defends them. So your system is protected against those many attacks. So if you have inbuilt zero-day attack based defense system, so it means that when defense comes to you, attack comes to you, vulnerability comes to you, so your system is capable of defending. Right? So that type of mechanism we want to develop, but hardly you can see that for new attacks, new type of viruses, systems are not basically capable of. So, but our aim is to exhaustively think about the attacks. So in this 4-day session, we'll try to make you basically think about the different type of attack spaces, so that maybe at initial level you can come up with a model, robust model, which can protect you against several type of attacks. But we cannot guarantee about all the attacks, because attack space is infinite. But certain type of attacks you can, of course, you can enforce that these type of attacks we can ensure certain guarantee that it might not happen, or with very less probability it might happen, but that might be very rare. So we'll discuss that, and of course I'll see that I'll ensure that you people will be demonstrating it here. So if you have, I think we have some lab session, we might have. So you will see that you will write your own code, attack code, you will write your own defense code. Then you will feel that, oh, it's very simple and people are doing it. It is not very hard. Only the same thing we are using for defense, the same ingredient logistics is used for attack. Okay. So this is the basically learning system. So before moving ahead, I am just trying to tell you how learning is happened in AI system. You have a data, past data. We try to come up with certain pattern in the data that happened in the past, and that leads to certain basically decision making or certain output, right? Certain response. So based on that input and data and response, we try to find certain pattern, right? And that pattern we try to mimic mathematically. So in computers, you know that everything is math, right? So whatever computation we are doing, so generally we say that at very basic symbolic language that we use, a symbolic representative we use in computers is binary language, right? So we say that every computation be represented as a stream of binary numbers 0 and 1. But if you go to the physical level, I am just discussing the semiconductor level because the whole talk is basically focused around the CPS, cyber physical system. So we have to think about the board level as well. So how 0 and 1 is represented in the system, how the computation is happen. So because you have a semiconductor chip, right? So you have to say that what is 0, what is 1. Yeah, he rightly said that we have the voltage, right? So low voltage, you have a certain threshold, certain range. If you say that if your voltage is high, you say that it might represent 1. And in one sense you can say presence or absence. Another story for storing data in binary format is presence and absence. That comes when you say that you are storing your data on devices. Not on the semiconductor chip, you are storing on some sort of magnetic chips or magnetic devices. You can say presence is 1, absence of anything is 0. So this way basically we try to store the data, right? And that happens in our basically modern devices that we have, storage devices, computing devices that we have. So they work on this principle. So symbolically we have binary, then after binary you can say that if you come to the programming or higher end programming languages, you can say we have instruction sets, right? So in assembly we have instruction set, then later on you can say in higher level languages you have abstract level of instruction set. You can say that if you want to sum two numbers, you can write in a basically a very natural, you can say natural way, you can say the way human thinks. You say that okay, you have to read two numbers, right? Then you have to perform add operation, then the result it is stored somewhere. It might be displayed on display devices. So these are the steps we generally follow, and I think everyone knows this one. And this systematic step of computing the things we call algorithm, right? We have a systematic way of computing, so we have steps, so we call it algorithms. So if it is in some mathematical representation, and if it is aligned with certain programming language, we call it pseudocode. Pseudocode sabko pata hai? So some sort of instruction flavor is there, right? So language instruction flavor is there. Algorithm is basically very generic. So any language, either procedural, declarative, or any object oriented, or any language you can use to implement that any algorithm, right? So here the learning process is that we have a data, past data, you have a certain response to the data. We try to develop a mapping from input to output, so that any input vector comes to us, input data come to us, so we try to respond, right? So the idea is basically heuristic. You can say how we basically do this. So everything what we do in AI is heuristic. So if you know anything, any incident that is certain. Suppose I say that in math you know that 2 plus 2 is 4. So if you say that you are designing a program AI algorithm or any model which just do addition 2 plus 2 equal to 4. So there is no need of this. You can come up with a definite system, right? Correct system which can just tell you that if you are adding two numbers, like 2 plus 2 is equal to 4. So there is no chance. But if you say that no, if 2 plus 2 equal to, it might be 3.99, it might be 3.84, it might be 4.1, it might be 4.2. You have certain uncertainty in the operation, right? So whenever you say that when uncertainty is there, then there are two important mathematics concepts we use. One is the randomness, the other one is probability. We try to see as a human that given many options, suppose you want to reach from Hamirpur to some place, maybe Manali, you might have many routes to go. Which one will you choose? So one is the shortest, and what are the others? So there might be a possibility that the shortest path that you have chosen, it might be narrow, right? It might be narrow, right? So maybe some vehicles are coming, and maybe you have one side very deep you can say valley, and you have another where you can say another path which has basically 5 kilometer long, but it is very safe, and so it means that certain uncertainty is there. So when we do so, we say that okay, what is shortest? So shortest, of course, you have deterministic approach to do it. You know that how many kilometers it is long and how many kilometers or other route, other path is long. You can decide directly, but the challenge, there are different challenges, environmental challenges, right? Maybe some roads might be broken, some construction might be happening. So these things are dynamic, right? So that you have to think. So certain uncertainty is there. So if you are using those uncertainties in your model, then we have to reach from here to Manali, right? But we have to choose the path heuristically. So I can just tell you my third age story. So one more story. So when I was driving towards NIT Hamirpur, so we had two paths. Then I decided to follow the highway, NH. So we have one more path. So that were coming to villages and many other places near from Pathankot, right? So at that point, so I decided to follow highway. Even there was a traffic, it's saying that it is 10 minutes. Google was saying that you have to go that path because of the time, but we follow another path because of the heuristic that we have, right? If Google might have that heuristic, so that path, designing system, or you can say that recommendation system, so it might have given us the idea that you just follow the highway, right? Even it is 10 minutes long. And it should, right? Because highway might be safer. It might not be narrow. It is basically dynamically updated, more dynamically updated, right? So that's the challenge. So if you want to develop a system, so many times if you see that human decisions are required, so we need AI system. Everywhere you cannot put AI. हर जगह AI नहीं लगा सकते. You cannot put AI everywhere. You have to think whether uncertainty is there. Is human intelligence required? Right? Some decision making is required. If that is the story, you can deploy AI system. You can come up with the AI system. Simple AI system you can use. You just say that okay, if this happen, if that happen, then you have to decide on this. This is called rule based system. So in ATS we were working on this one, right? So we have expert systems. So those expert systems were the rule based systems. So with the past data, we have certain heuristics, certain knowledge, and based on that knowledge, we are able to make certain heuristic, and those might be the good heuristic. If you are not knowledgeable or you don't have a certain, basically, you are not basically perceived with many type of situations, you might not have a good heuristic. So, but if you have a good heuristic, your solution is good. If you don't have a good heuristic, your solution might be bad. So here the idea is, we have to map your input to the output such that, or once input is given, query is given, we have to respond, such that certain decision making is done, right? So if you have a deterministic system, we don't know, so we don't use this one. So we have a function, we have algorithm, we have direct approaches, right? So for example, if you some computation you want, right? So you want to multiply two numbers. So there is no need of any AI. You just develop some faster system to do the arithmetics on that, right? But if you see that if we need certain decision making, so in addition to these computing systems, you have to put a layer, you have to put a code or software or approach which can do certain decision making. So here it is not directly. So suppose you say that you have two features in the data, input data, you just add two features, you will get the response. If this is the case, then there is no need of AI system. But the AI system comes into picture when you say that it is not exact. So you can say that if you add two features, it will give something, and based on that something, we have to decide something, right? Then AI comes into picture. So ये बहुत जरूरी है हम लोगों को समझना, right? So we should understand that why and when, why and where and how. So how we'll discuss. When and why, maybe you can learn through experiences, right? So one basic fundamental I have told you, that when you see that uncertainty is there, you can deploy AI. And there are a lot of places, lot of systems we have uncertainty that depends on the human decision making. So that's why we need experts. Then you can replace those experts with AI modules. Even you cannot 100% replace it. You need expert of expert, right, to monitor it. So that's the story here. And this also poses a lot of questions. Maybe you can ask that if you don't need expert, you need only experts of expert, right? Then there is no need of expert. And this way you can say that that is challenging for the job opportunities. It is true, by the way, in one sense. Nowadays you can say a lot of jobs, coding jobs, by the way, for the students. So they are very few in the market because of these AI generated tools. Copilot, so have you heard Copilot? Even in ChatGPT, you just go and say that, can you write a program for this in some language? So that is capable of writing the code. Only the thing that is required, that code might not be correct, it might have certain bugs. Because of the versions in different packages, you need expert. So only the job is for the experts who can identify the bugs and who can fix the bugs. Because industry don't need the people to write the code, so code can be written by AI models, right? These generative models, we call it generative AI system. We'll discuss in this course. In the last day, I think we have a generative adversarial neural network. So we can generate attacks, we can generate the data which can do attack. We can use that generative AI to basically defend our attack system or O-level system also. So here you just see that learning process is given the past data, given responses, you try to mimic certain functions, certain mapping, which can learn the pattern and acts accordingly, like your real data, right? So whenever real data comes to you. Then in real data, you can say you have a real data. Once your model is built, you have trained the model. How you are going to train it, right? Just, I think it is that. Okay. So how are you going to train it? So it is immaterial for the client. Client does not require it. Client needs a system which is basically reliable, secure, right, and useful. So you can just give your real data as input. You will get the prediction response, and accordingly you might have certain actions. You can do it, right. So there is a history of AI. So by the one I have already discussed in the inaugural sessions. So just told you. It starts in 1642, and then you can say the first neuron model 1943, the third one. Can you see? So because we need computation. So if you say that you need computation, so it means we need computing unit. So most of the computing unit, or you can say a good computation unit, was developed during the Second World War, right? So idea was to decode the messages. Right. So we had basically in 1940s, you can say a lot of innovation happens. By the way, from the First World War, right? So countries basically pumped money in this development of the computers, right? And first, you can say if you know that Fortran language, and many of you might be heard the name Fortran. Abhi to Python mein kaam karte, right? So everyone knowing Python. But in the first high-level language that we are using was Fortran. So Fortran was developed in 1950 around, so 54, 52, 51. You can say that time. And after that time, so the first neuron model was in 1943. It was published, right, in 1943. It was binary neuron. So you say that you have a compute unit. So they try to mimic the human brain. So just say that there is some stimuli in the brain, maybe they say that neuron, and if certain response from the body is basically went to those neurons, it says that it has to activate or not, it has to act or not. So they said binary representation, and binary values they used. So weight was binary. Later on it was basically Uh, for continuous domain, you can say for real numbers, real weights, and you can say nonlinear activation was developed in 1960s, you can say. So one of the conference was there in 69, I think, 60s. So people used neuron. So neural network model was the first, you can say, AI model that was in picture, that is available in the articles and literature. And modern day we are studying that thing only. So deep learning era or generative AI era, so we are using only the neural network model. Right. In some sense, in some, you can say some flavor of that neural network model. So basic computation unit is the neuron only. So everyone talking about the generative AI, and basic building block of that basically generative AI is neuron. So we'll discuss that in coming sessions. So time, you can just tell me. Okay. So we have this history here, evolution of artificial intelligence. You can say that neurons in 1943, then 1950 invention of Turing machine, then in 1956 the world this artificial intelligence basically world came into discussion. Okay, earlier it was the world was not there artificial intelligence. Everyone was intelligent, naturally intelligent, right? Okay. I will share these slides, don't worry. So I am coming to one of the recent slides. Yes, can you see this one? So we started basically deep layered neural network architecture. So when we have hardware accelerators in the picture, like Kepler and others. Nowadays we have GPUs like NVIDIA H100, right, and other flavors, and even we have AMD GPUs. And TPUs also, right? Google has TPUs, tensor processing unit. So GPU basically, you just say computation is value-based computation, one value with the other value. So generally these basically graphics processors, you can say, they can do computation if your input is vector, right? So they are very fast to do the computation on vectors. And same is true with the TPUs, so tensor processing unit. So in tensor processing unit, we say that okay, you have a 2D vector of, you can say matrix of 4 cross 4. So they can do 4 cross 4 matrix addition, multiplication as a one single abstract operation, very fast, in a very fast manner. So that's why TPU is there. So latest GPUs, they have TPU, dedicated TPU core. If you have a large matrix to operate, so they have those computations. So that's the reason, because neural network, all the neural network operations that we do, so they can broken as a matrix operations. Or you can say higher dimension vectors, you can call it tensor. So tensor operations. So in the forward pass, if you know neural network, I think many of you might be aware of neural network. So the forward pass, we try to multiply the weight matrices. In the backward pass, in the learning pass, you can say, we compute the gradient, and you know that the size of the gradient is same as if you are saying that you have a vector, you want to compute the gradient with respect to some scalar, the output size is same as the vector, right? So if you take the gradient of a tensor, the output is tensor. So the operation that we do in the backward pass, so we'll discuss in tomorrow's session when we do the optimization. That is again matrix multiplication. So whole neural network, you can say the learning process is matrix multiplication, addition, or tensor operations, you can say. And learning process, or you can say backward pass, is also the tensor operations. We are multiplying matrices, or adding matrices, right, or vectors, you can say. So both way we are doing the same thing, right? So that's why we need, if we have certain hardware, so these GPUs and TPUs are designed to perform tensor operations at a very faster pace. So that's why nowadays we have a lot of computations. You say that ChatGPT is the reality, DeepSeek is the reality, because we have GPUs, right? Because the core in GPUs is low cost, basically cores. We have many thousand cores GPUs, compute unit in GPU. But if you go to CPUs, central processing unit, that processor we have, so latest development is 80 core. Right. CPU can go to the Intel site and or AMD, so you can see that the core is very costly, and the processor CPU that you have 80 core or maybe the middle one is 40 core, you can say they are very costly. So in the same cost, you can say that GPU might be very cost effective, and you can do the operation computation. Nowadays you can get these GPUs in the cloud also, so they have these compute units. You just send your data to Google Compute Engine. I think many of you might be knowing. Even Colab, right? Everyone knows Colab, Google Colab. So in Google Colab you can hire GPUs, right? So A100, I think 40 GB they in the Google Colab Pro, right? You can get it, right? So you can do computation on that. So earlier the free version is Kepler 80, I think, so they are providing, right? So in the free version of Colab, if you don't get license, basically Colab Pro, so by default they have Kepler 80. So Kepler 80 has a low core, less number of cores, but A100 40 GB and 80 GB, so they are the basically advanced GPUs. You can say a story of 1 year only. Then later on we have H100, and nowadays we have H200 and higher versions. So China trained its DeepSeek on 16,000, I think 2,000 H800 GPUs, right? And ChatGPT, the 4th version, right? The current one, so it was trained on 16,880 GB GPUs. Because at that time you can say only these were the invented by NVIDIA, right? A100. They grabbed and they used it. Nowadays you know that the story. So this is the GAN. So till 2014 you can say we started using GANs. So GAN are very popular models. So generative adversarial neural network. So when I say adversary, so you know that what is adversary. Adversary, you can think of a critic, right? The person who can criticize the thing, right? So adversary. Adversary is a very you can say lucid, or you can say very simple word, but adversary can do anything. It can do harm to the system. It can attack to the system. That's why the name is adversary. Can you fool the system, right? So if you are fooling the system, we call it adversary, right? So adversary can do any adverse thing to your system, so we call it adversary. So we'll see that using this generative adversarial neural network, how can we design the adversaries which can basically fool, which can basically attack to the model, right? So there are many types of attacks. So popular attack is cloning attack, I told you, right? Given a model, you can come up with a different model which is capable of doing the same thing, a similar thing, and you put it in open source, right? That might harm to the company. Another one is if you are capable of, your model is capable of generating the data on which the model was trained. Suppose I say that you have a face recognition system in your organization, and somehow I am capable of getting all the faces on which the model was trained. Right. So what can we do? So we can generate adversarial sample which can disguise a person. So we can disguise, right? So we say that okay, I am person ABC. The ABC is registered or authenticated person who is allowed to basically enter in maybe very secure room or secure system that was opened using your biometric face recognition system. So I can enter. So that is called membership attack, right? So if you are able to generate the data on which the model was trained, right? So that is a data privacy attack, you can say. You know that who is authenticated on this machine, who are the persons. And there are many ways you can attack, right? You can abduct that person, right? You can do harm to that person. So many things you can do, right? So that's a challenge. So we'll see that can we generate a model which is basically capable of defending adversarial attacks. We'll see GAN can be used to do the same. So it can use to design the attack, it can use to defend against the attack. So we'll try to make a robust system which can basically defend against these adversarial attacks. So we'll have a one session on that, by the way. So one whole day on adversarial attack. So we'll be discuss about the different mechanism that basically the attacks that are done on machine learning as a service, because nowadays all the models are deployed on cloud. So any app that we are using nowadays, right? So which basically does AI, that uses AI, so that is on cloud. So we have to make our model secure so that no one can harm it, right? No one can attack our model that is used as a machine learning as a service. Then we see that lot of things happening here, and we'll discuss the GPT, generative pre-trained transformer, in the same direction, and we'll discuss the vulnerability in GPTs. So how can you attack GPT? So can you design a query such that it can basically attack your GPT, right? GPT system. So how will you attack it? You can say, how can you sense the attack? So you can say, suppose you are asking some query, it is not giving you the correct response. So you have designed a query such that your model is not capable of doing correct decision, right? So that type of attack we'll try to do maybe in hands-on sessions sometime at the very last day, by the way. So because till that time we will be capable of designing the attacks and defense. Then we'll see that what, and even you can assess the model. So what type of basically problems a particular given machine learning model, or you can say machine learning is a service, that model that is on cloud, it basically carries, right? For example, bias. So bias detection you can do that, if whether your ChatGPT is biased towards certain community or not, certain region or not, right? Certain maybe gender or not. You say that if you are talking about some, if you are asking query regarding a certain gender, or some maybe female asking question, or you can say male person asking question, so its response is different. Can you see that, is it true or not, right? Whether it is biased towards that or. So these are the research problems. So you can say this one, when we say GIAN timeline and all the things that we are discussing here, so these are the research topics. Then another thing is basically, can you explain the things? So whatever your model is giving you, response is given by the model, is it correct? So how will you basically ensure that this is correct? So that, yeah, that you might not have. Suppose you have purchased face biometric here, face system, face recognition system, or some fingerprint recognition system. So how will you ensure that you are going to pay certain cost, right, and it will work for your organization? So the answer is explainability. So if I am a company and I want to sell something, so I will tell to the client that why our model will work, right? So whatever response is coming to you, so why the response, this response came. So we have to provide the explainability to the model. So this is the modern research. Only 3-4 years people started thinking in the direction that, of course the era is AI, right? So can you provide explainability? Then another basically debate is on the ethical uses, ethical basically production of AI tools, AI system. So ethics I will not discuss much. I have already told you that it comes to, it is basically relative things. So when it comes to defend the borders, when it comes to basically serve the society, so the ethical things is little changed, right? So ethical AI, then explainable AI. So explainability will discuss how your model is secure, because security security can be tested only when threat occurs, when vulnerability occurs. Suppose you say that I am selling you an operating system which is capable of certain attacks. So as a client, how will you ensure that whatever the person is saying, whatever the company is saying is correct? So many times you cannot design that attack and test it. So company says that we have tested on these attacks, the performance of our model is this. Many times you can rely on that, many times you cannot rely, that is another story. But if company says that we have these attacks, and this is the blueprint for those attacks. These are the report. You see the report, you might get certain reliability on that. You will buy it, right? So that is done through explainability. You have to explain whatever your model is capable of doing. Then one modern, basically, school of thought is AI for AI. So AI for AI concept is not new. So you can say even for languages, programming languages, you can say most of the higher end programming languages, high level programming languages are developed in C language. You can say language of language, right? So C language, most of the things in C language is developed in C language. Most of the module in C language is developed in C instruction set, C language. So that is basically language for language, you can say. The similar thing is AI. So we are developing the code, we are deploying the models in AI, and we are trying to do analysis of that model using AI, right? So we are building the trust using AI. So that is called AI for AI. So whatever we are defining, so that is AI is used for AI. For example, code writing. If you want to write a code, you are using Copilot, right? So AI is used to write the code, and AI is right. So we are using AI for AI, right? So that is the modern concept people are doing in that direction. So this is another line here for the deep learning. So it started from the AlexNet in 2012, or you can say 2010. Then later on, the modern one, generative AI, we have starting in 2023, and nowadays you have ChatGPT, right? DeepSeek and many more models, Google, Gemini, and others. There is the history, so I am not going into this. So this is the basically adaptation. So how people are adopting this AI technology. So this is the growth. So because of its successful nature or successful stories that we have nowadays, so it has exponential growth, right? Starting from 2022. So just post COVID, you can say. You can say that a lot of development happened during the post COVID because people have time to think, right? They stayed their home and they don't have a lot of busy schedule at that time, like moving here and there, right? So you can say there was less pollution at the time, so mind was charged at that time. But it has different other things as well, right? So these are the basically some applications, right? AI technology landscape where we are using these technologies. So the popular you can say domains where we are using AI technology, the defense, right? Academia, healthcare, right? Tourism, transportation, and blockchain is also used in transportation. By the way, right now people started thinking. Apart from the cryptocurrency, they started using in different aspects, right? Blockchain. So maybe we can start. We can stop here. I think we have to stop.